So good morning all and welcome to this lecture of electronics, and I will be teaching you semester 1 syllabus. Hopefully the last unit, semester 1, unit number 4, that is the last topic of that unit number 4, that is JKMSFF. And we have already studied about JK flip-flop, I guess. So we have studied what are the drawbacks of JK flip-flop, and these drawbacks of JK flip-flop are being rectified in JKMSFF. So whenever a question comes that what is the drawback of JK flip flop, then you will have to write that JK flip flop you have a race around condition in which if both the inputs are 1, then the output is race and it toggles between that output. So that is the race around condition, and that race around condition is being eliminated in the JKMS flip flop. Now in this JKMS flip flop we are having two JK flip flops, and we give the clock pulse by inverting the clock pulse from the first input to the second input, right? So I will draw that JK flip flop, and as you know that the JK flip flop how looks like this. So we will be having two RS flip flop like this with the clock, sorry, with the clock, and this two is being connected to the AND gate like this. So we will be having two AND gates with three inputs like this, and the first input is given to the clock of the circuit, and the second input is the J and K, okay, and the third input is being feedback. So I will keep it floating right now, and after that we will connect this. So this is the first JK flip flop. The second flip flop is same, so we'll having Q and Q bar like this. The second flip flop will be again the same, so we will be having the another RS flip flop like this, R and S, and again now we will be having three input AND gate like this, and the first input we are connecting it to the clock. Now this clock is, and the second input is directly given to the JK flip flop like this. So I guess this is visible for you, and if it is clear, I guess I have drawn it a little bit higher. So I'll just make it like this. Okay. So this is that gate, and these are again R and S. This is Q and Q bar. So these are the outputs likewise. So this input to this AND gate is now been feed back with the output of the last, that is the Q bar, and this output of Q is being feed back to this, the first input, as we have done it in JK flip flop. The second one, that is the clock. Now here the clock plays a very important role, and this clock is given to the second JK flip flop through a inverter, right? So whenever this is being inverted, then only the output will come across the output of this. So we are having two JK flip flops, the first JK flip flop and the another flip flop. So we call this first flip flop as the master flip flop, and the another one from here, the next flip flop, that is the slave flip flop up to here. So this is called as a master slave flip flop. So this flip flop is a master flip flop, and this is a slave flip flop, right? So the whole we call it as a JKMSFF, JKMS flip flop. Right now, how the toggle is being eliminated over here, that can be seen by using the inputs, right? So the main operation of toggle is when the outputs of the inputs J and K are high, right? So whenever we are having this J and K as high, so depending on the clock pulse, like this, we are having a clock pulse, right? In the clock that we are giving over here. And as you can see, this clock is being given to the another flip flop through an inverter. So it will be the opposite of the clock will be opposite of what we are giving here over here, right? So it will be opposite. So whenever we are having high, which implies that these two AND gates will be enabled that time, and as soon as it becomes low, then these two AND gates are going to be enabled. So up till then, what will happen? The output which is fed over here comes across this first master flip-flop, and it remains over here until the clock changes to low, right? So this JKMS flip-flop works on the lower going edge, right? So as soon as the output or the input of this clock goes low, then the output from over here transfers to the output. Rest of the truth table will remain the same as we have studied over there, right? But now the main important portion of JKMS flip-flop is it is going to work on the negative edge. So this is the negative edge which comes from the higher to lower, higher level to low level. That is called as a negative edge. This master flip-flop is going to work on the positive edge, which goes from low to high. Is it clear? It goes from low to high, right? So this master flip-flop will work on high, and this slave flip-flop is going to work on the negative edge. And this is how the toggle mode is being reduced. Rest, the truth table of the flip-flop remains the same. Have you understood this? Right? Now let us check with the truth table. I guess we are having a little space over here. So I will try to draw the truth table of JK flip-flop like this. So we are having three inputs like this. So we are having this clock, then we are having J, K, and Q. So these are the two inputs and the output. We are checking here Q only, right? So we have to consider the initial conditions also. So when this clock is 0, then this is at the don't care condition, and the output of Q will remain no change, as we have studied in the rest of the flip-flop. So the output will remain no change. So the first output is no change, right? So when clock is 0, J and K are at don't care. I guess this is not visible from there. So it is don't care means I have written X over there. So this is at don't care. So the output will remain no change as there is no input going into the clock, right? Second, when this clock goes low, now this clock is going to work on the negative edge. So that's why I have written a arrow which is pointing towards down, right? Which shows that this flip-flop is going to work on the negative edge, right? So I am writing like this. So when the clock goes low, then only the output is going to change. So consider the first condition that when J and K are 0, 0. When both are 0, 0 again, if both are 0, then the output of this gate will be disabled. This will remain as it is. As soon as this will remain as it is, so all the output will remain as it is. And we can again write that it is NC, that is no change, right? So it is a no change, right? Second, when the second edge is high, then we will be having 0 and 1. So K is 1 and J is 0, right? So if J is K is 1 and J is 0, okay, yeah, so this should be S and this should be R. Yeah, I have written it like, yeah, this is S and this is R. So when J equal to 0 and K equal to 1, right? So when K equal to 1, which means in this situation we will be having three conditions. The first conditions are if the Q is high, Q is equal to high. The second is clock is equal to high and K is also equal to high. So then only when all the three conditions means clock, K and the output Q are high, then the gate B and gate B will be enabled and the output of B will become high, right? So clock is high, okay, and then K is high and the output Q is also high. So we have to consider all the initial conditions that we can give to the first AND gate. So as soon as this becomes high, the output of AND gate B will become high and it will go to the reset, and as soon as it goes to reset, the output of Q is going to change to 0 and this will change to 1. Okay, now if you look at the clock, this is 1, this is high, so automatically this will become 0. So nothing is going to be inputted inside the second flip-flop. As soon as this output goes low, the negative edge comes, this will change, this clock will become 0 and this will become 1. As soon as it becomes 1, again Q bar is 1 and clock is 1. So gate D, I am writing here gate D will be enabled, the output will become 1 of B and it is given to the reset terminal of the second slave flip-flop, and since it is 0, so output of C will be 0. So as soon as reset is 0, the output of Q will change to, it was earlier it was equal to 1, now it is going to shift to 0. So as you can see over here, this flip-flop is going to work on the negative edge, right? Though the output of the first flip-flop is going to change on the positive edge, but the total output of the flip-flop is going to change on the negative edge. Therefore, I am writing here as the down arrow, right? Because it is going to work on the negative edge, right? So the first flip-flop, now it is going to 0, that is reset. The output Q is going to change as reset. Second, when I am giving it again negative edge, and if I am giving J equal to 1 and K equal to 0, here again we have to consider all the three conditions. Here we can say that Q equal to 0, or Q bar is equal to 1, right? Then we are having clock equal to 1 and J equal to 1. So if this is the situation, means Q bar equal to 1, J equal to 1 and clock is also equal to 1, K equal to 0. If this is the situation, then AND gate A is going to be enabled, right? And the output of AND gate will become 1, this will become 0. So the input is given to the set terminal. So the output of the first flip-flop will switch to 1. So it will remain set up to when up to this clock is high. As soon as it goes low again, now the output will be shifted over here. This will become 0. So again, this is high and clock will become higher as soon as it reaches to negative edge. So the AND gate C is going to be enabled and the output is going to have 1 and this will become 0. Again, the input is given to the set terminal. So automatically the output of Q is going to shift to 1, right? So we say that the flip-flop is set or it becomes 1, right? And the last situation where we are having the toggle mode, that is if Q equal to 1 and J equal to 1 and K equal to 1, clock is also equal to 1. So if this is the situation, then the flip-flop toggles. But how it toggles? It will toggle on the negative edge, right? So if I need to show that diagram according to the clock pulse, so if I draw this as the clock pulse of, I guess it is visible, it is actually a square wave pulses which are given to the flip-flop. So this is the clock pulses that are supposed to be given to the clock, and this is the negative edge. If it is visible, so these are the negative edge, and if I look at the output, that is Q, and if I say that this is equal to 0 at this point, right, and both J and K are equal to high, then how it is going to switch? So it is going to switch. Why? As soon as the negative edge will come, it will become high and it will remain high up till when? Up to the second negative edge. Then again it will shift to 0. Then again it will remain to 0 up to the next negative edge and it will again shift to high to the negative. And as you can see in the toggle mode, JK flip-flop was going to switch using the propagation delay time in that particular high time of the clock pulse. Here it is being switched to twice the timing period of this. So if you are able to see, if I call this time period that is equal to this. From here I am taking to here. So if this time is capital T, so you can see that this time is being doubled from here to here. So it is approximately equal to twice of T, right? So we call it as a time multiplier or frequency divider, right? We call it as a time multiplier. So one bit can be converted into twice of two bits, right? So this is the JKMS flip flop, Jack King Master Slave flip flop. We are having two JK flip flops over here. I guess you have understood the truth table also, and here we will be having toggle mode, but that toggle is going to work on the negative edge, right? So this is the diagram of JKMS flip flop. I will again explain you the construction of JKMS flip flop. So here in JKMS flip flop, we are having two JK flip flops, right? Connected back to back. The clock of the first JK flip flop is being inverted and given to the second, right? So this is being inverted by using an inverter over here and NOT gate. This is a NOT gate, and it is being given to the clock of the second flip flop. And why it is called as a master and slave flip flop? Because as the master gives the input to the slave, then only the slave will work, right? So then only the slave is going to give the output, and therefore they are called as master and slave. So if master gives the input, master orders the slave, slave works accordingly, and therefore this is called as a JKMS flip flop, right? So we are having two AND gates over here, two input AND gates, two AND gates over here. One AND gate, one input of the AND gate is being connected to the clock. The another inputs are connected directly to the outputs of Q and Q bar of the first flip flop. Similarly, here in the first portion, that is in the master portion, we are using three input AND gates, right? Where the first input is being made common and given to the clock. The second inputs are taken as J and K. The third inputs are being taken as a feedback from Q bar and Q, right? So this is the construction of the JKMS master slave flip flop, right? And this eliminates the race around condition, which was there in present in the JK flip flop. That was actually the drawback of JKMS flip flop, right? So which we have eliminated in JKMS flip flop. So this is supposed to be the last topic of unit 4 of paper 2 semester 1. So I guess by this we are going to complete this unit, and thank you for watching my lecture. And please go through my YouTube channel. I will be uploading more videos on my YouTube channel. So stay tuned. Please like, share, and subscribe my channel. Thank you. Thank you very much. See you in the next class, same time. Thank you. Have a nice time. Good day.